In this question, we're asked to consider the molecule H2S. We want to know the central atom, how many lone pairs around the central atom, the ideal angle, and how the ideal angle compares to the actual angle. To answer these questions, we need to draw the Lewis structure. And if we want to draw the Lewis structure, we have to start by counting the valence electrons. So in this case, we have 2 times 1, because we have 2 hydrogens, plus 6, which is 8 electrons. Usually we put the least electronegative atom in the middle, but hydrogen never goes in the middle, so we put sulfur in the middle, and then we bond it to 2 hydrogens. That is 4 electrons, 2, 4. So now I want to add 2 lone pairs on sulfur to fill its octet and use up the 8 electrons. I want to minimize the formal charges. Remember, hydrogen doesn't like an octet. It just likes to have 2 electrons around it. It wants to have 1. It has 1 from this bond, so therefore it's neutral. Sulfur wants to have 6, and it has count the dots as 1, count the dashes as 1. 1, 2, 3, 4, 5, 6. So it wants 6, has 6 electrons around it, so it's also neutral. This is a good Lewis structure. Now, we can answer at least the first question and the second question, because we know the central atom is sulfur, and we know that the sulfur has 2 lone pairs. Now it asks, what is the ideal angle between the sulfur and hydrogen bonds? So, what we need to do is figure out how many domains we have. So domains. Count the atoms as a domain and count the lone pairs as a domain. So we have 1, 2, 3, 4 domains, or said another way, the steric number is 4. And then how many of those domains are lone pairs? So in this case, there's 2 lone pairs. So if we look at the sheet from Wikipedia, 4 domains, 1, 2 lone pairs, the molecular geometry is bent. So here, the mg, or the molecular geometry, is bent. But we can also calculate the EG, or the electron geometry. And the electron geometry is based on the fact that there's no lone pairs. So the electron geometry is tetrahedral. 2 of these are lone pairs, and 2 of them are hydrogens. So this is the fundamental shape that it's going to be. So the electron geometry here is tetrahedral. The ideal bond angle in a tetrahedral molecule is 109.5 degrees. And you can look that up in your book. It just is. What VSEPR is essentially geometric shapes that put the electron pairs, whether they're bonding or non-bonding, as far apart as possible. However, lone pairs of electrons tend to sit closer to the atom and take up more space. So because they take up more space, this HSH bond angle would be 109.5, but these guys are bigger. These lone pairs are bigger, which makes this less than 109.5 because it kind of squeezes in this bond angle because these are larger. So here the answer is smaller. In water, I believe the bond angle here is 104.5. In H2S, it's probably slightly larger than that because sulfur is a bigger molecule. However, it's certainly less than 109.5, less than the ideal angle because of the lone pairs.